It's 1967. The parking lot is full of chrome, stripes, hood scoops, and noise. Big blocks rumble like distant thunder. Hemis bark with that unmistakable mechanical aggression. 427s scream toward redline like they're trying to prove something to everyone within earshot. Everyone's watching the loudest engines in the room. Magazine photographers are snapping pictures. Teenagers are crowding around open hoods. Grown men are arguing about cubic inches and quarter-mile times. And sitting quietly in the background is a small, unassuming V8 almost nobody is talking about. No racing stripes, no magazine covers, no bragging rights, no crowd gathered around its engine bay. Just a 318 cubic inch Chrysler LA engine, ticking over smoothly, waiting to outlive almost everything around it. Most people have no idea how this engine survived when bigger, stronger, louder V8s burned out, cracked blocks, failed emissions tests, or got regulated into extinction. And what almost nobody realizes is that the 318 didn't just survive by accident. It didn't stumble into longevity through dumb luck or favorable circumstances. It survived because it was engineered differently, built with restraint, and designed for a future nobody else was preparing for. You think you know Chrysler's V8 story? Not like this. Back in the early 1960s, Detroit was locked in a horsepower arms race that bordered on insanity. Bigger displacement meant bigger headlines. More cubic inches meant more magazine covers. Every manufacturer was chasing the next benchmark, the next record, the next bragging right that would translate into showroom traffic. Chevy had the 396 and was pushing toward the 427. Ford was developing the FE series with increasingly aggressive configurations. Chrysler had the legendary 426 Hemi, an engine so dominant on the track that NASCAR had to ban it, and big B and RB blocks like the 383, 400, and 440. Those engines were absolute monsters, high compression ratios pushing 10.5.1 or higher, huge bores that left minimal material between cylinders, massive torque curves designed for straight-line acceleration, and absolutely brutal demands on fuel, parts, and drivetrains. Insurance companies were starting to notice. Fuel economy was laughable. Maintenance costs were climbing, but nobody cared. This was the golden age, and everyone wanted in on the action. But while all that chaos was happening at the top of the performance ladder, Chrysler engineers were quietly working on something else entirely. Something that didn't make noise at car shows. Something that didn't generate breathless reviews in Hot Rod magazine. They were developing a lighter, more compact, small block family meant to replace the aging A-Series engines that had served Chrysler since the 1950s. Engines designed not for glory, but for duty. They called it the LA series, Lightweight A. The name itself tells you something about the philosophy. This wasn't about making headlines. This was about making progress, reducing weight, improving efficiency, building something that could work harder with less. And in 1967, the 318 LA stepped into the lineup. On paper, it didn't look impressive to anyone chasing horsepower. A 3.91-inch bore, a 3.31-inch stroke, total displacement 318 cubic inches. In a world where 400 cubic inches was becoming the baseline for serious performance, 318 sounded almost quaint, like showing up to a drag race with a sensible sedan. Compression ratios were modest, usually around 8.51 to 9.2.1 depending on year and application. Horsepower ranged from about 230 gross horsepower in early high-compression versions, dropping to 150-170 net horsepower in the smog-era years when emissions equipment strangled everything with an internal combustion engine. Numbers like that didn't excite anyone in the muscle car crowd. Nobody was writing songs about the 318. Nobody was putting posters of it on their bedroom walls. But Chrysler wasn't chasing glory with this engine. They were chasing balance. And that decision would prove more important than anyone could have predicted. The block was thin wall cast iron, lighter than older designs, but still remarkably stiff under load. Chrysler's engineers had studied the stress patterns in engine blocks and optimized the ribbing and webbing to maintain rigidity without adding unnecessary weight. The result was a block that could handle more than it needed to while staying manageable for mechanics who had to work on it. The crankshaft was beefy for its displacement, supported by wide main journals that distributed load evenly. Some engineers at the time thought it was overkill for an engine making modest power numbers, but that overkill was intentional. Chrysler wanted margins. They wanted an engine that was never running near its limits. The connecting rods weren't exotic. They weren't forged from race-spec materials or designed for 7,000 RPM operation, but they were overbuilt for the power the engine actually made, which meant they rarely failed under normal use. And here's the key thing most people miss when they dismiss the 318. This engine was never pushed to the edge. While big blocks were running massive bores with cylinder walls so thin you could almost see light through them, the 318 stayed conservative. Cylinder wall thickness was generous, sometimes a full quarter-inch in spots where it mattered. Cooling passages were well thought out, designed to pull heat away from the cylinders evenly. Oil passages were simple and reliable, without the complex routing that could clog or fail in high-stress applications. The cam profiles were mild. Valve springs were designed for longevity rather than high RPM performance. Everything about this engine said, "I'm here for the long haul." It wasn't flashy, it didn't turn heads, but it was calm, and that calm mattered more than anyone realized. Because by the early 1970s, everything changed. Emissions regulations hit Detroit like a sledgehammer that nobody saw coming. The Clean Air Act of 1970 forced manufacturers to slash compression ratios almost overnight. Suddenly, engines that had been designed to run on high-octane leaded fuel had to work with regular unleaded. Camshafts got milder, timing got retarded, exhaust systems got choked with catalytic converters, horsepower ratings collapsed across the board. Engines that had been designed to live at the edge of performance suddenly couldn't breathe. The big V8s suffered the most because they had the most to lose. High-compression 440s turned into detuned gas hogs that delivered big-block fuel bills without big-block performance. Ford's venerable FE engine family faded fast, unable to meet the new standards without sacrificing everything that made them appealing. Chevy's 454 struggled under the weight of emissions gear and increasing pressure for better fuel economy. Even Chrysler's own 383 and 400, engines that had defined the brand's muscle car identity, lost their reason to exist. Buyers who had once celebrated cubic inches started seeing them as liabilities. Insurance rates climbed. Gas prices spiked during the oil crisis. The entire value proposition of the American V8 seemed to collapse overnight. But the 318, it barely flinched, because it was already built for moderation. Lower compression meant it could run happily on regular unleaded fuel without detonation or knock. The engineers hadn't designed around premium fuel, so the transition was painless. Smaller bores meant better flame travel across the combustion chamber and more complete combustion, which translated to better emissions numbers without as much additional equipment. Shorter stroke meant less piston speed and less stress at cruising RPM, which meant the engine could handle mild cams and retarded timing without feeling completely gutless. At 2,000 to 3,000 RPM, the range where most people actually drove during their daily commutes and highway cruising, the 318 was smooth, quiet, and efficient. It did exactly what most drivers needed it to do, without drama and without complaint. And here's where things get interesting. While muscle car fans were mourning lost horsepower and writing angry letters to magazine editors, fleet managers, taxi companies, police departments, and everyday drivers were discovering something else entirely. These engines just wouldn't die. Taxi fleets in major cities started reporting 200,000 miles without major rebuilds. Cab after cab rolling up mileage that would have destroyed lesser engines. Drivers didn't baby these cars. They didn't follow break-in procedures or use synthetic oil. They just drove hard every single day. Police cruisers presented an even tougher test. These cars idled for hours at a time, something that's murder on most engines due to carbon buildup and oil contamination, then ran flat out on the highway during pursuits. Day after day, night after night, the 318 just kept starting. Trucks hauled loads they had no business hauling with a small V8 under the hood. Contractors and farmers who couldn't afford the fuel bills of bigger engines discovered that the 318 could handle their work without complaint. Mechanics started noticing something strange. They'd pull a valve cover after years of abuse and neglect, and the valve train looked clean. Bearings showed minimal wear. Cylinder walls still had visible cross-hatching from the factory honing. Oil consumption stayed minimal even after decades of service. One Chrysler tech reportedly joked, "You change the oil and the engine gets bored before it wears out." It wasn't just marketing spin. These engines genuinely outlasted expectations again and again, and there was a reason for that. The LA Series oiling system wasn't exotic or complicated, but it was consistent. Oil fed the mains reliably under all conditions. The hydraulic lifters were forgiving of dirty oil and extended service intervals, important in an era when many owners didn't follow maintenance schedules closely. Cam profiles were mild enough to reduce stress on the valve train, but strong enough to make usable torque where it mattered. And torque is the secret that nobody talks about when they discuss the 318. A typical 318 made around 260 to 280 pound-feet of torque depending on configuration, not headline-grabbing numbers by muscle car standards. But it made that torque out early, right off idle, exactly where drivers needed it for pulling away from stoplights, merging onto highways, and maintaining speed on grades. This low-end torque meant the engine didn't have to work hard to move heavy vehicles. It operated in its comfort zone during normal driving, rarely approaching the RPM ranges where wear accelerated. Meanwhile, bigger engines that relied on high RPM and aggressive cam timing to make their peak numbers suffered under emissions equipment. Exhaust gas recirculation raised intake temperatures and reduced power. Lean air-fuel mixtures, mandated by emission standards, caused detonation and burned valves. Catalytic converters added back pressure that choked high RPM breathing. The 318 just shrugged and kept going, and Chrysler leaned into it. Throughout the 1970s and 1980s, the 318 became the backbone of the entire brand. It went into Dodge D-Series trucks that worked construction sites and farms, Ram Chargers that took families camping and hunting, Diplomats and Grand Furies that served as police cars and taxis in every major city, Chrysler New Yorkers that carried executives to meetings, vans that delivered cargo, motorhomes that crossed the country. Anything that needed to start every morning and keep running got a 318. By the late 70s, output dropped as low as 150 net horsepower. Journalists mocked the numbers. Performance enthusiasts shook their heads. But reliability went up. Fuel economy improved. Emissions compliance became easier and cheaper. Insurance companies didn't punish buyers for having a 318 under the hood. And while other V8s quietly disappeared from order sheets, the 318 stayed. Even when Chrysler introduced the 360, the bigger small block in the LA family, the 318 remained the workhorse of the lineup. Why would Chrysler keep both engines? Because the 360, with its larger 4.0-inch bore, ran hotter and drank more fuel. It made more power, sure, but it also wore faster and cost more to maintain. The 318 was cheaper to insure, cheaper to maintain, and more forgiving of owner neglect. There was another hidden advantage that few people understood. That smaller bore allowed thicker cylinder walls throughout the block. Thicker walls meant less distortion under heat, better ring seal even after extended high-temperature operation, longer life before needing a bore job. You could overheat a 318, let it cool down, and it would often survive without permanent damage. The thick walls resisted warping. The modest compression meant head gasket failures were less catastrophic. Try that with some high-output big blocks with their paper-thin cylinder walls, and you'd be shopping for a new engine before the radiator stopped steaming. This forgiveness factor made the 318 invaluable for owners who didn't have the time, knowledge, or money to maintain vehicles perfectly. It tolerated mistakes that would have killed other engines. By the 1980s, the 318 had evolved into the 318 Magnum, new cylinder heads with better port design, improved airflow for better power without sacrificing efficiency, roller camshaft that reduced friction and wear, multi-port fuel injection that replaced carburetors and improved cold starts, fuel economy and emissions. Horsepower climbed back up to around 230, torque hit about 300 pound-feet. Suddenly, the engine that had spent years as a utilitarian workhorse was making competitive power again. And once again, it wasn't the biggest engine in its class. It wasn't the fastest. It didn't win comparison tests or generate enthusiast excitement. But it was there, still running, still starting, still working. Production numbers tell the real story better than any performance specification could. Chrysler built millions of 318 LA engines over more than 3 decades of continuous production. From 1967 into the early 2000s in various forms and configurations. Few V8s in American automotive history had that kind of lifespan. Few engines of any type maintained production relevance for that long. Meanwhile, legendary engines burned bright and died young. The 426 Hemi became a myth, discontinued after just a few years because it couldn't meet emission standards and cost too much to produce. Today, original Hemis sell for more than some houses. The 440 vanished from the lineup, too thirsty and too dirty for the changing world. Chevy's classic small block evolved so many times it became something else entirely, losing its original identity through decades of revisions. Ford's Windsor family survived, but not with the same quiet consistency or the same reputation for indestructibility. The 318 didn't win Le Mans. It didn't dominate drag strips. It didn't inspire posters on garage walls. It never became the engine that teenagers dreamed about owning. What it did was something harder. It outlasted them. Today, more than 50 years after the first 318 LA rolled off the assembly line, you can still find original 318-powered trucks starting on the first crank after sitting through cold winters. Engines that have never been rebuilt, blocks that have never been decked or bored, cranks that have never been polished or turned, bearings that still show minimal wear after decades of service. That's not luck. That's not coincidence. That's engineering discipline. The 318 LA proves something uncomfortable in automotive history. Something that runs counter to the stories we like to tell about American performance. Bigger isn't always better. More horsepower doesn't always mean more success. Sometimes the engine that wins is the one that doesn't try to impress anyone. It just does its job. Every day, for decades, without complaint, without drama, without needing attention. So the next time someone laughs at a small Chrysler V8 or dismisses the 318 as the boring option, remember this: when the noise faded, when the regulations hit, when the fuel changed, when the insurance rates climbed, when the market turned its back on excess, the 318 was still there, quiet, reliable, and very much alive. If you enjoyed this deep dive into one of Detroit's most underrated survivors, let me know in the comments what engine story you want next. Another forgotten workhorse that deserves recognition? A legendary failure that everyone remembers wrong? A rivalry that changed the entire industry? And make sure you subscribe, because the best automotive stories aren't always the loudest ones.